Hi, my name is Yusuf Abdul Gaber. I'm a undergraduate researcher here at Marshall University, and I've spent the last year working on solar cell inkjet printing. It sounds complicated. Specifically, copper indium gallium selenide solar cells. Uh, we'll get into that in a bit. Let's start off. Well, what's a solar cell? Well, a solar cell is just a simple device that it takes photovoltaic energy in and knocks electrons out of their uh, out of their valence shell to create a voltage, and then we can generate electricity. To put simply, right? Well, there's a lot of ways to do that. A lot of different types of solar cells. So there's a new type called it's a newer type, newer than the silicon-based, known as copper indium gallium selenide. Instead of being silicon-based, it uses CIGS nanoparticles or CIGS particles to create a layer, and then cadmium sulfide on top, and then zinc oxide for a conductive top layer. And this is ultra thin. Normal solar cells are thick, very thick compared to this. This is as thin as a sheet of paper, or thinner. It's ultra thin, much thinner. It's amazing, but that introduces complications. The idea is though, thinner solar cell. It's we'll get into that now actually. It's flexible. It's so thin you can even put it on a little thin sheet of plastic, like plastic thin film, and you have yourself a flexible solar cell. Well, that's interesting, right? That opens up the opportunity for us to do roll-to-roll manufacturing. You can have a solar cell roll. You can have that as a sheet that you coat on a vehicle or something. And as you can see, CIGS cells, they're the most efficient of the newest generation of solar cells. With the best silicon crystalline cells, crystalline is in there rigid, right? They can't flex or anything. They hit 26% efficiency. CIGS cells now are hitting 23.3% efficiency, and they're better than every other alternative, every one of them. And they're the most viable one too. So far. You know. As you can see, here's a graph of the different types over the years. Oh yeah, there's organic solar cells right here. The only issue with those is you put them in the sunlight and they break down, which it defeats the purpose of a solar cell. But don't want not get into that. So here's the issue though. We were given the promise of roll-to-roll manufacturing, roll-to-roll manufacturing, right? That's beautiful. You could have a solar cell roll, continuously. You know how much cheaper it would be. But no, this is what we're stuck with. Right now, the only viable method is to go. Yeah, the only viable method is that futuristic machine that you saw a second ago. Essentially, it's like some science fiction movie where they use an electron beam to sputter the solar cell, the net, to sputter the CI. It's called sputtering, right? I don't know why I can flip back to that image. Interesting. Anyway, sputtering is where you use an electron beam to literally you vaporize you vaporize the CIGS particles, and you put your substrate, your glass sheet, inside of a vacuum chamber and everything. It's very expensive, very complicated, not impossible to do roll to roll. You need argon gas. Anyway, roll to roll manufacturing like this is what we want. Well, how can we do it? Well, there's a new way. If you've heard of ink, well, there's something called nanoparticle ink, where you put the CIGS particles as a form of nanoparticles embedded within a solution, right? The solution contains the CIGS nanoparticles, and then we can start doing stuff with it. We can start coating that, because that's what we're going for. We're going for that coating. Right, the issue is you have to have a controlled growth of a very thin film. If you do it, you can sputter it on using an electron beam, which is great, but not what we want for industrial production. Nanoparticles, size comparison, most of them are about 1 to 100 nanometers. In comparison to a soccer ball, that's like a soccer ball in comparison to the Earth, which is pretty cool. So a lot of nanoparticles. This is what nanoparticles ink looks like. Essentially, that's the copper indium gallium sulfide selenide Well, some of the samples. There's a lot of samples. Embedded within a solution. Well, what would we do with that solution, right? Because now we have the solution of copper indium gallium selenide. We need to somehow coat that onto a substrate in a thin, controlled manner. This is where it gets controversial, right? There's so many different researchers trying different ways to coat it really thin on there. Some people have even tried taking a knife and just scraping it on there real thin, but you need it to be very, very controlled if you want a good solar cell efficiency. If you want to even compete with the sputtering machine, we need to get it into gear, right? Because those high efficiencies were actually done through a sputtering machine, not through non-vacuum based methods, the poor man's method in a sense. These methods have only gotten up to about 16% efficiency, and it's not ideal. But that's what we're working on, though, right? Here's more samples. These are foggy because there's oxygen within the solution. This is not good. This is the problem we're struggling with right now, actually. If you make the solution wrong, it becomes foggy because of contaminants. So this is how we get a really thin coating in the lab scale. What you can do, right? This is how they got that 16% efficiency. You take a small square of glass, very small square of glass, and then you place it on a very fast spinning machine, and you drop your solution on one by one, and it sprays out a super thin layer. See the video. Oh, as you can see, the vacuum is sucking the glass substrate down. Starts spinning. Oh, look at that. Oh, I always love that. And it kicks into top here. We already put the drops on there, by the way. You don't drop it on while it's spinning. And now we got a really thin film. Very cool. Anyway, well, here's the issue. That's great and all, but how do I get roll-to-roll manufacturing? I mean, that's the idea. What's the point of going through all that effort to make a non-vacuum based method if you can't do roll-to-roll manufacturing? So we've all heard of inkjet printing, those dang printers that never work, but if what I did is I've taken a home printer, your home printer, I've opened it up and modified it so that it can actually accept any custom ink, and I can even control the ink droplet patterns, because that's what we're trying to do. We're trying to create a thin film, and as you can see, this is a little example of what your inkjet nozzle is doing. All it's doing is it's a little nozzle, the ink goes in, and it taps it like that to squirt out the ink onto the substrate as it moves. So this is my printer. This is the one that I modified. Those are what I did is I took refillable ink cartridges. Right now we're only testing it out with water because it's very hard to clean out the nanoparticle solution, and we're still working on getting good efficiencies on the spin method. But once we get a good efficiency on the spin coating method, then we can put it in to the printer and then just print out our solar cells. This is on aluminum foil, but we're probably going to use copper foil. Using copper foil. Here's another of the same video. It's essentially the same. But this is the circle. Oh, gotta watch my time. Anyway, sorry, same video. And here's a cool little clip of the the droplets under a microscope. They're actually supposed to be much better distributed, but because of the surface tension of the water, the droplets actually tend to collect. But it's still interesting looking at it under a microscope. You can actually see them evaporating in real time. But with that's not good for if we're you know the because we're gonna have a much better continuous film with the nanoparticles. That won't be an issue, even if it does evaporate, because we're just trying to get the particles, not the solution. Anyway, and it's not easy though. It's been very challenging. There's so many factors that go into it. This was one of my most disappointing results. It took a long time to clean that powder, and then it turns out it was all just oxidized. And this is some of the results of trying to get a nice little solar cell on a substrate of glass. But that's how it is. That's how it is. Uh, I hope to get good results soon, but thank you for attending my presentation. That is an attempt right there of getting a solar cell on a small glass substrate. Hopefully it all goes well soon, God willing. Thank you for attending.